Okay, so let's begin the ARIMA, the modeling. So he says, drawing upon the software from Hindeman et al. And working with one economic measure at a time. So he's going to do each time series individually. Now here's the interesting part. Now I'm not familiar with this particular function in the forecast program, but he says our program searches across a large set of candidate models, including autoregressive, moving average, and seasonal components. So this is really pretty extensive. I'm not exactly sure how many models they actually go through, but that's a lot. And then it selects the very best model in terms of the Akaike information criteria. So this would be some kind of measure of what is a good model. In other words, how closely the model fits the data. And there are different ways to decide about whether one is good or better than another. So this is one measure of that. Then, having found the model that the algorithm determines as the best model for each measure, we use that model to forecast the future values of the economic measure. So if we're doing consumer sentiment, we'll use that to forecast future values for consumer sentiment, and so on. He says, in particular, we ask for forecasts for a time horizon of 2 years, or 24 months. We obtain the forecast mean as well as a prediction interval around that mean. In other words, we're going to say, okay, well, I think in 1 year, I think the consumer sentiment's going to be at 120 or something like that, and then we're going to say plus or minus a certain amount. So he says we obtain the forecast mean, that would mean like 120, as well as a prediction interval, plus or minus 10 or something like that, or plus or minus 20 or whatever, around that mean for each month of the forecasting horizon. So we're not just going to predict 1 year, we're going to predict 1 month in the future, 2 months in the future, 3 months in the future, and 4 months, and so on, into the future. Now, as we go further into the future, we expect that the uncertainty will be increasing, right? So that means that the interval will be expanding around the mean, and you'll see that in the pictures here. So he says look at figures 5.3 through 5.6. So let's look at that. So here's 5.4. I don't know what happened. Oh, sorry. Here's 5.3. So this is the original data. This is the past data up to here. And then this is the prediction. So the model that was chosen by the algorithm then predicts that in the future, this is what the employment rate is going to move like this. Okay? And so this is the prediction, and this line, I guess, goes up and down and up and down and up and down and up and down. And then at the same time, this is the interval, and you can see that the interval is expanding as we move forward further into the future in our predictions. And so you get the same kind of thing here. So this one is for new orders, and so it predicts that it's going to be like this, but the interval starts out as plus or minus this amount. You can see it gets plus or minus more and more and more as we move into the future, which is what you would expect. And the same thing with the other ones as well. This one and this one. He says it calls it a megaphone effect of the figures. Okay, so now he gives us some clues as to how to go forward, but he doesn't actually go forward. So he says the next step in our work, we might fit a multivariate time series or vector autoregressive model to the 4 time series. In other words, we might try and put them all together and make a prediction having 4 inputs instead of just 1 input. So we'd have as inputs into the model all 4 series, or just all 4. We just have 4 values as inputs, 4 variables as inputs. Alternatively, we could explore dynamic linear models, regressing one time series on another. So that's another thing that we could explore. We won't have time to do anything like that here in our class. We could utilize ARIMA transfer function models or state space models with regression components. So these are all, like I said, we could spend 45 lectures on this subject, so there's a lot to explore. The possibilities are many, as are the modeling issues to be addressed. So you can read this comment here for more information. Next, on page 61, he gives us some references to look up if we want to explore it further. He mentions some stuff regarding R. He says we build on the foundation R code provided by this person. And you can look for the reference at the, well, if you purchase the book, you can look for the reference to this. Useful for programming with dates are R functions provided by these people. Okay. And finally, he refers to, he says that we also run the Granger test of causality, a test of temporal ordering. Temporal ordering means what comes first, or what's causing what. But it's a kind of subtle issue, but the question of causality is different than sort of predicting. One thing predicts another, and one thing causes another is a little different. And anyway, you can read about this on the internet. Find out about the Granger test of causality. The interested reader should also check out a delightful article that answers the perennial question, which came first, the chicken or the egg? And that's this one. Okay, now let's look at the code that we have, and I'll go to that in the next video.